Okay, for this deep dive, we're focusing on a piece of technology that is literally sitting on the side of a building right now, probably keeping your internet running.
Yeah, and you'd never even notice it.
Exactly. We are talking about the Thor Broadcast F-Node Day. And this isn't some consumer gadget. It's, a quiet, rugged workhorse.
That's right. Our mission today is to sort of cut through the jargon and explain why this little box is so crucial. It's basically a bridge.
A bridge between what?
It catches that incredibly fast light signal traveling over fiber, and it converts it back into the traditional CATV radio frequency that copper cables can actually handle.
The 45 to 1,000 megahertz range.
Exactly. And you can tell it's designed for the outdoors just by looking at it. That clamshell, weather-resistant case, it's built to be bolted on the side of a building and forgotten about.
It has to be tough.
Right. And that survival really depends on how well it does that conversion. It all starts when the light hits the pin photoelectric converter.
Which is just a fancy way of saying it turns light into electricity.
Pretty much, yeah. It translates photons into electrons. But the real magic, I think, is what happens next in the amplification stage.
Okay, tell me about that. We saw it relies on gallium arsenide, or JA's, amplification. That sounds, a little high-tech. Why that?
Well, it's an engineering choice. It's about signal quality over, say, saving a few bucks. JA's gives you exceptionally high gain, but more importantly, really, really low distortion.
And that matters because?
Because you're taking one pristine signal and potentially splitting it to dozens of homes. Any distortion just gets magnified. You need it to be clean.
Okay, so we have a clean signal. How do we physically connect it? I noticed it demands single-mode fiber, and specifically the S-key APC connector. Why so picky?
It's all about stopping reflections. S-key APC, the APC stands for angled physical contact.
Angled?
Yeah. The tip of the fiber is polished at a slight angle. It's a tiny detail, but it means that any light that might reflect back, it bounces away from the source instead of right back into it.
So it prevents interference.
Exactly. You need an absolutely perfect point-to-point connection on the input side.
And on the output, we need enough power to send it across the neighborhood, right? It's got those dual RF-F-type connectors. How powerful is that signal?
It's rated at 108 dB or more. To put that in perspective for you, that's powerful enough to feed a dozen or more homes right away. No need for another expensive amplifier right after it.
It's designed to be the starting point of that local network.
Precisely.
All right, let's talk about what makes this thing so reliable out in the wild. The first thing is the optical automatic gate control, the AGC.
Yeah, the AGC.
I like to think of this as like cruise control for the light signal. Is that a fair analogy?
That's a perfect analogy. It makes sure the performance is optimized, even if the input power from the fiber fluctuates a little bit.
As long as it stays in that negative high to plus 2 dBm range.
Right. It just smooths out any of those little variations so the output is always consistent. And it's flexible, too. It can handle both the 1310 or 1550 nanometer bands.
But the real testament to the engineering have to be the rugged specs. I mean, this isn't in a nice climate-controlled server room.
Oh, not at all. This thing is designed to operate from minus 40 degrees Celsius
Wow.
all the way up to 60 degrees Celsius.
What?
So Arctic cold to desert heat, and it can handle up to 95% humidity. It's just not going to be the reason your network goes down.
And for the technician on site, there's some internal controls too. A test node and dials for EQ and ATT. Why would an installer need to mess with those?
You have to tune the signal for the specific location. EQ is equalization that fine-tunes different frequencies to fix signal quality issues across the cable.
Okay.
And ATT is attenuation. That's just a fancy word for a volume knob. You're adjusting the overall power level to match what the copper line needs. It's all about that last-mile precision.
So when you boil it all down, what this means for you, the listener, is that this F-node is this. Surprisingly tough and specialized little box. It's a bridge between the massive speed of a fiber backbone and the reality of local cable distribution. It's what makes it all work.
It's the silent guardian of reliability, really. When you think about how fast we're building out fiber networks, that last little hop into the building is always the bottleneck.
Yeah.
And the engineering in this one component, from the GA's chip to that extreme temperature rating, it just highlights how much resilience is built into the infrastructure we use every day.
Yeah. And it really makes you think, if this one compact box handles such a critical, complex transition so flawlessly, what does the future look like when we finally get rid of that last mile of copper altogether?